Hey, good morning. So this is an odd place to be in a podium. I usually like it to be in the middle. But today we're going to talk about some of the challenges with Spark and some of the solutions that we're presenting from IBM to solve those challenges. One of the biggest challenges when you use Spark on-premise, and this is a big distinction, right? What we're really focused on is on-premise, where Databricks is very focused on cloud and software as a service. When you try to do Spark on-premise, you run into all of these challenges where when you have multiple teams using Spark, the infrastructure that they're using often is siloed. In other words, every group has their own Spark instance. They aren't doing multi-tenancy. They aren't able to really share that infrastructure. And often the infrastructure and the Spark implementations aren't being scheduled efficiently. They don't get the right throughput from the infrastructure. So you run into a lot of scaling issues, you run into a lot of performance issues, and you also have infrastructure that's being wasted. The other really big challenge in this space is once you look at enterprise level Spark, and some of the biggest banks are using our Spark implementations, what we see is that they have a big requirement for security. But what I mean by security is it can be things like a user being able to access data that otherwise would be limited to kernel access. Right? How do you provide that in a secure and efficient way for that user-based program? So those are some of the challenges that we deal with. And the offering or the product that we have here is a software product called Spectra Conductor. Spectra Conductor is a product that ships with Spark embedded in it. And of course, now that Delta Lake is out there, we will put Delta Lake in Spectra Conductor so if you're looking for an on-premise Delta Lake, we'll provide that in Spectra Conductor. But this is really what unlocks all of these scaling issues that you see. Right? You're able to, with Conductor, schedule the resources much more efficiently, schedule all the different instances, provide multi-tenancy on the infrastructure, and do this at a very low latency, right? So what it does is it really delivers faster results with a better TCO, and we have all of these security features built in around authentication, around user access of data that make it easier to actually do your data pipelines and your data platform. So really to go much more deeper into Spectra Conductor, I'm going to turn it over to Steve Roberts, who will actually go further into details.
Okay, thank you, Sumit. Yeah, so as Sumit was just saying, Spectra Conductor is all about optimization of resources and optimization of the users and teams exploiting those resources. So this is just a graphic that sort of shows the before and after, right? Going from the siloed model that Sumit was just talking about to really a integrated resource pool environment where it's a shared multi-tenant infrastructure. So what this really means is rather than separate teams building dedicated islands in this on-premise environment, you have your IT organization bring those resources together into a pool. And by adding the efficient resource management and scheduling capabilities of Conductor, you bring the resources, you schedule the jobs to the resources, and have them only consuming those resources for the period of time required, and then they can be reallocated to other jobs in the environment, including advanced policies for prioritization, lending, and borrowing, which essentially means you can very much dynamically reallocate the resources as the jobs are scheduled and come into the environment. So this means better utilization rates across resources, therefore either running more work or doing it with less systems. And it means faster results to the line of business users or the data scientists who are actually exploiting this environment. And we've, as noted in here, we obviously focus a lot on Spark as a particular optimized workload that can benefit from this shared multi-tenant environment. But it's not just about Spark. It's really about bringing different data science analytics workloads, including notebooks, Anaconda, Cassandra. You'll see some examples further later in this presentation, together to really share across this shared pool. So it also gets rid of islands where you have Potentially you have Hadoop clusters where you have your storage and compute locked for Hadoop purposes. You have then multiple Spark clusters. You may have some running Mongo. You can bring all these together under this framework and get that value of optimization and more faster turn on your investment in terms of the line of business users. And we've done, I'm just going to move ahead here just to talk a little bit about some of the results that we've seen. I'm going to resize this on my screen because it's really small here. I don't want to keep looking up. So this is an audited benchmark results. The SMB2 benchmark. This shows a variety. I know that a little bit small, but it's a variety of different multi-user, multi-tenant workloads, both long-running, short-running. And in all cases, shows the performance of our Spectra Conductor scheduler, session scheduler, resource manager versus Yarn and Mesos. So this is identical resources, identical workloads running with these different scheduling solutions, right? So simply by having a more intelligent use of the resources and a smarter session scheduler that can both predict needs and reallocate resources as the jobs free them up, we can get much higher throughput in terms of jobs per hour, I believe, in this case. And the results vary depending on the workload mix, but in all cases, faster results, meaning better value for the business, and back to the other point of less resources required to drive them. So lower TCO, faster results, faster analytics. That's really the 1-2 punch of this. And again, this is audited, so it's not just an IBM cooked up benchmark. Now, as it relates to intelligent resource scheduling and job scheduling, you want to know what capabilities, the capability match between the resource requirements and the job are obviously critical. And part of this is making sure that accelerators such as GPUs are properly used. So with our scheduler connection working with the Spark scheduler, we can ensure that Spark jobs that are able to exploit GPUs will actually be the ones sharing those GPU resources fairly and getting the priorities allocated for GPU consumption. So this means that slightly more expensive nodes within your compute environment with the GPUs are being used where they should be rather than just CPU-only workloads, which should be run elsewhere. So this is about getting the best allocation possible for optimized workloads as well. Beyond just intelligent scheduling and resource management, there's other unique optimizations in Spectrum Conductor that can actually just make Spark run faster. This is just one of them concerning being able to share RDDs across applications and across users. So rather than the construction time of building these RDDs and these data sets, every time a Spark job is created, we can actually cache RDDs that then are reused for future submissions from additional users and additional jobs. So this actually can huge savings in terms of the startup time for workloads. I think TensorFlow workloads can, TerraSort, type workloads can take 30 to 40% of their time just in terms of this RDD construction. So this tears down the initial barrier to actually getting your data loaded and ready for use. And of course, as enterprises scale, they can take more and more advantage of this shared construct to get quicker results. And of course, the multi-tenant environment, you want to know what's going on in terms of who's consuming the resources, right? So we've actually invested a lot in bringing this ELK workload in terms of monitoring and management right into the platform so that someone administering this cluster can see how the Spark executors are being used across the different applications and how they're being shifted. Of course, there's a set of, as I mentioned before, policies behind this, so you can create policies for fair share scheduling and lending and borrowing of resources. If one job is claiming a certain amount of resources, doesn't use them, they can be borrowed by another job, and just prioritization. So very advanced policies. These policies are based upon over 2 decades of really hardening within the HPC environment. The same core scheduling capability here is used to manage 1,000-node HPC clusters at some of the largest institutions in the world. So we're really bringing forward that capability into this next generation Spark MLDL workloads to get that same kind of benefit to intelligently optimize a very precious commodity within an enterprise. So that support's built in. And as I mentioned, This is, Spark is certainly a focused workload. It actually comes with a complete open source Spark distribution, actually multiple distributions. The one thing I didn't mention earlier is that this, one of the reasons why some of the silos get created that Sumit mentioned is that the different teams actually need different environments, right? One needs Spark X.Y, the other one needs A.B. And so the different life cycles of Spark as it relates to the workloads end up creating these silos. In this case, you can actually mix and match different instances of Sparks, different versions of Sparks, even different potentially optimized versions of the same level of Spark running within the same shared cluster. So this solution takes care of that lifecycle version management, and so that the tenants only are using the versions that they need, and we'll control change within that environment. However, lots of other frameworks, and by frameworks I'm saying that very generally, databases, SQL engines, MLDL environments like TensorFlow, Caffe, notebooks, Jupyter, Zeppelin. So this is really very versatile in terms of adding this fabric to both accelerate Spark, but also this broader array of full stack capabilities. And while IBM storage is an optional complement to what we're doing with Conductor, it can actually provide some really key benefits as well. Both our Spectrum Scale, which is our distributed file system that scales to billions of files, also from HPC heritage and IBM over the last couple decades. Rock solid resiliency, providing multiple interface support, SMB, POSIX support, NFS support, HDFS, all within a single scale-out file system that's sort of software defined, so it's storage agnostic. You can deploy this on any variety of different storage models. And it has unique integration with Spectra Conductor, so the same isolation that applies to tenants in Conductor, the workload consumers can also be passed on to the data set. So the data is also secured within that tenant, and you can protect and isolate the data just for that consumer, which of course is important in these type of shared infrastructure environments. And then of course, for many applications, cloud object storage still makes sense in terms that lower cost object storage, and it can fit in directly as well into the storage layer within Spectrum Conductor, or as a tier behind the file system for, say, doing archive or backup storage can be pushed to the cloud object storage tier. But I just want to emphasize, Spectrum Conductor is storage agnostic, just as it's sort of compute agnostic, right? It's about being able to build shared resources of compute attached to any variety of different data sources, and being able to dynamically allocate and use those resources to execute your Spark workloads or your other MLDL workloads. But this is a great combination to bring these together. Also, since this is an IBM session talk, we want to talk about our hardware component briefly. So IBM has a power system brand for scale-out servers that are great for big data analytics. We actually have one on the floor at our booth, so come and talk to the team, and you can hear about some of the benefits of Power 9 processor, the unique capabilities that we have with NVIDIA in terms of the acceleration between the CPU and the GPU with the NVLink 2 technology. And this is one of the benchmarks we've done on that Power 9 generation of systems that's showing the benefit of driving down price performance just for pure open source Apache Spark. And we certainly expect that optimized versions as we work with the Databricks Delta Lake and other evolutions of Spark will continue to get great results on these processors because they're really tuned for high throughput workloads. Now, just to kind of cover a couple use cases, and then we'll have some time for questions, hopefully. So this is just a client environment with Spectrum Conductor in action, which does include the Spectrum Scale component for the distributed file system I just mentioned. Their use case is really about this high-performance ETL. So they have a lot of different ETL workloads coming from different sources. A lot of them, most of them now using Spark for that execution. So they wanted to pool all these ETL workloads together into this common shared Spark grid, which they've now built up on Spectrum Conductor. And it was very important to them it's data agnostic, because they're pulling data from a wide variety of sources, as you can see here. So they run this accelerated transformation steps on this shared Spark environment, take advantage of those performance enhancements I mentioned earlier about the shared RDDs and the effective scheduling to load clean data into their data warehouse environment. So this is running 50 plus nodes of Conductor and driving a huge number of Spark jobs to do this data pipeline cleansing. And this is one of the top banks, top global banks. And lastly, just to kind of close with another use case we're working with a number of customers on is that this same capability for shared compute infrastructure separated from storage is great for underpinning a wide variety of MLDL workloads. So we've actually rolled this up in an IBM solution called Watson ML Accelerator, which includes this smart Spectra Conductor scheduler, optionally the Spectra Scale distributed file system, but importantly, a full set of support for open source MLD environments and unique optimization for things like distributed deep learning, large model support that can specifically exploit that high bandwidth pipe I mentioned with the NVIDIA GPU and the Power 9 processor. And to do this in a way that's sort of agnostic to the data sources, where you can have your data scientists being able to gain access to cleanse workloads using Spark for ETL transformation, but also then using the same environment for running their MLDL workloads, whether they're using TensorFlow or Caffe or their environment of choice, along with support for the typical programming languages in that environment. So that wraps up the content. I would invite everyone to visit the booth, the talk. We both have a session on Conductor there, a PED, one on IBM Power and one on IBM Storage, so please come and talk to the team. So with that, we have a few minutes to field questions. Yes, this gentleman here.
Can IBM Spectrum Conductor run on commercial distributed file systems, such as Weka or Cumulo or Cobyte?
Yeah, we're essentially, I think, agnostic to the file system, but I'm going to look to some of my colleagues. The question was, does Conductor run on just any general commercial distributed file systems other than Spectrum Scale? So guys nod if the answer is yes. Yes. Any other questions? Sure. Don't be shy. A couple minutes. OK, well, Sumit and I and some of the technical team are around as well. Thanks for coming to our session. I know given the title was IBM, you may not have known what you're going to get out of this. So hopefully it gave you a little bit of information about some of the technology we're working on with our open source partners, such as Databricks. And hopefully we can talk to you at the booth a little bit more. Enjoy the rest of the show.
Awesome. Thank you so much. Give him a big hand.